Hi, this is your review for your Triangle Basics quiz. You're watching this if you missed class. We did this exact same. It says quiz number 1 up here, but we treated it like a review, and then we went ahead and took our quiz. So my suggestion is, as I go through each question, take the piece of paper that I've given you with these problems and write everything down. That way, you'll be able to use this on the quiz in just a few minutes when you take it on your own. Okay, so question number 1 says find the value of x. And all of these values of x are in degrees. You can see the little degree sign. And we remember that the triangle has 180 degrees. So we're going to add the 116 and the 32. And I can add that here pretty easily. And then we'll subtract that from 180. And if you're having trouble subtracting that from 180, feel free to go over here to the Desmos calculator. 180 minus 148, and that gives us 32. And we're done with question 1. Question 2 says, in the triangle below, angle K is a right angle. Suppose that the measure of angle J is 2x plus 10 degrees, and the measure of angle L is 3x plus 15 degrees. Write an equation to find x. Make sure you use an equal sign in your answer. So in the ALEKS, what you would be doing, excuse me, is you would take one of the angles, and it doesn't matter which one you start with, and then a second angle. And then this is where you have to be really careful because a lot of people forget the 90. That's why I wrote it in. And then it doesn't actually ask you to solve the equation, but it does say find the degree measure of each angle. Notice that with the exception of angle K, which is 90, we can already go ahead and do that one. In order to find angle J, we need to know x, and in order to find angle L, we need to know x. So I think by now we're probably realizing that we have to type it into the Desmos calculator and solve for x. So let's do that now. 2x plus 10 plus 3x plus 15 plus 90. And I'm just going to, see, I messed up already. Just going to make sure I did that right before I check the answer. Yes, I did. I always like to check. Sometimes I type wrong. And I get x is 13. So what I'm going to do is write that down on my paper so that I don't forget it. And then I'm going to look at angle J, since that's the first one listed. Angle J is 2 times x plus 10. So if you don't want to do that math, 2 times x plus 10. So that angle is 36. Oops. Escape. There we go. And then we'll do the same thing for angle L. Let me just silence my phone real quick. Volume. There we go. So 3 times x, which remember was 13, plus 15. So 3 times 13, just type that here, 3 times 13 plus 15 gives me 54. So I'll write that in here. And then the interesting way that you can kind of check this is if you want to just add those up, 36 plus 90 plus 54, at least you have an idea if you made any big mistakes. And see, that's adding up to 180. So that's a real quick little check you can do. Okay, question 3. We're working at the halfway point here. We're going to have to go to the next page. Question 3 says, for each set of 3 lengths, determine if they can be the side lengths of a triangle. So you're given it's basically 4 problems. You have problem 1, problem 2, problem 3, problem 4. And it says we're determining can be the side length or cannot be the side length of a triangle. Now, this is where you need to remember our way of doing this is to check the 2 smallest sides. So I'm going to go through here and highlight the 2 smallest sides. And then you need to add them up. So 5 plus 10 is 15. Is that bigger than the third side? Now 15 is not bigger than 32. So I would click on the cannot be side lengths of a triangle button. Over here, we'll have 16.5 plus 4.4. And again, if you don't like adding that up in your head, just jump over here to the Desmos calculator and add it up. 16.5 plus 4.4 is 20.9. Okay, so I'm going to write that down. Is 20.9 bigger than 20.4? And yes, it is. Not by a lot, but it is bigger. So we're going to click the button can be side length of a triangle. Here we have 7 plus 3. Pretty easy. That's 10. Is 10 bigger than 22? No, it's not. And then we have 13 plus 4 is 17. Is 17 bigger than 13? Yes, it is. And that's how you do question 3. Now, question 4 says the side lengths of a triangle are 11 and 16 and x, which means we do not know the third length of the side of the triangle. So it says determine the possible values of x. Write your answer as an inequality. So this is one of those questions where we're going to write it like that because it only wants you to use x once. So this is where you would need to click this type of thing, whatever that button is on the right, you would need to click that twice. Let me see if I can show you that real quick. Hang on just a sec. Now it's just asking you to write it. I might be able to preview it. Give me just a quick sec and I'll show you what that looks like. So what you would do here, and this is the way I always do it, I take the less than sign and I click it once and I click it a second time. And then I put X in between it in the middle like that. Okay. So for this one, we have 13 and 20. So whichever problem you want to do, we have 11 and 16. It's going to be the same process. I would have clicked this twice. And so I'd have a box here like that. And then the X would be in the middle box. And then I'd have an empty box there. And so if you can recall, what we did was we added these two together. And that gave us the biggest boundary for the third side. And let's see, that's going to be 27. So that would go here. And then we would subtract them. 16 minus 11 is 5. And that would go here. So if we were looking at the problem I just showed you in ALEKS, let me give you a quick preview. So 13 plus 20 would go here. That would be 33. And 20 minus 13 would be 7. And that's what they would want. Okay? All right, on to question 5. Question 5 actually starts down here, and then it loops up to the top. So it says order the side lengths. And it tells you what the side lengths are from least to greatest. Now, if you look at the particular problem, they're going to give you already these inequality signs. So that would mean that the greatest one would go over here on the right, and the least one would go over here on the left. And of course, the middle one would go in the middle. Now, the problem with the problem, let me make some boxes here. Not perfect, but you get the idea, is that we are missing one piece of information. We're missing that. So we don't really know if the 83 is the big side or the medium side. We're pretty sure it's not the small side, but we don't know which is which yet. Until we have all three angles, we cannot figure out which is which. So what we have to do is we have to do 83 plus 56 and add those up. And then we have to subtract from 180 to get that third angle. And see, I get 41 there. And you could have done that math inside the Desmos calculator. That would not have been a big problem. But remember, we're going to do this from least to greatest. So hang on while I get a little shape for myself here so that we can cover up some stuff. Okay. And let me fill that in. There we go. Okay, so what I'm going to do is I'm going to cover up the small angle. And see, the 41 is the smallest angle. So I'm going to cover it up. And then the question is, which side is peeking out at me? Is it IJ? Is it JK? Or is it KI? And if we look right over here, you can see that K to J or J to K, this one right here, is peeking out at me. So that's the one that we're going to write in the box. So let me grab a different color. We're going to put JK right there. And what that's saying is that this side right here that is opposite from the smallest angle is the smallest side. So then I'm going to cover up the medium angle. And I only see K to I or I to K sticking out. Well, that's the medium angle, and what that's telling me is that the medium side is KI. And see, they're giving you the answer choices right here. You just have to select the one that goes in the box. And then I'm going to cover up the big angle. So now I'm seeing JI or IJ right there. So I'm going to write that there. And that's how you would do that. So in the ALEKS program, and I think you've seen these before, you would just be typing, I don't know if this is right or not, but you would just type right in the box like that. Okay, last problem. This is the part everyone hated the most. This is isosceles and equilateral triangles. They probably look very familiar to you. When we did this in class, I gave them a choice which one they thought was easier. And pretty much everyone picked the one on the right. And I think that's because that's the equilateral triangle. And the reason that I know it is equilateral is because they've given me 60, 60, and 60, which means all of my angles are the same. So if I tried to cover up one and find the smallest and the medium and the largest side, there isn't a small, medium, large. They're all the same size. So that means that all of the sides, if one of the sides is 13, all of the sides is 13. And so they're looking for AB, which is right here, and we would type in 13. Now, if they showed you something like this, where they gave you 13, 13, and 13, and they said, find angle C, and they went the other way, well, then you could say to yourself, okay, all of these sides are the same length, so the angles must be all the same length. So I'm going to split it up evenly, not 6, but among the 3 angles, and get 60. And that's where that 60 comes from. So it works both ways. Equilateral has the same number of degrees, 60 degrees for each angle, and it has the same length side on all three sides. The problem with this one on the left is it has these little tick marks. See the little tick mark here, little tick mark here, but there is no little tick mark here. So everybody's boo, it's not equilateral. So what I like to do, if I had a piece of paper in front of me right now, I would rotate it. But because I don't, and I'm on the screen, I'm going to redraw it. So I'm just going to rotate it around. And I'm going to put the 120. Now, what these little tick marks are telling us is that the triangle is isosceles, which means the angles that are right next to the tick marks are also the same size. Well, that's kind of helpful because if we know, we pretend like we're shopping here and we have 180 degrees in the whole triangle and we spent 120 maybe dollars at one store, we would have $60 left over to spend at the angle D store and at the angle F store. Now, you don't have to think of it as shopping, but I think it makes it easier to understand because if you know you have a fixed amount of money to spend, then it's going to run out at some point. Now, the thing that makes this problem a little bit different from many other problems is that angle D and angle F are the same. So we have to take this $60 or 60 degrees and we have to split it evenly among two angles, or if you want to think about it, among two stores. So that means we're going to divide by 2. 60 divided by 2 is 30. So angle F and angle D are 30 degrees. Now, if you had a triangle like this, let's put this here and this here, we're still going to make D and F and E, but let's pretend this was 35. Well, remember, our base angles are right next to the sides that are the same length. So that would make this 35. And then we would have to add these two up. Running out of space here. Give me just a second to get a little more whiteboard space. And that would be 70. And when we subtract that 70 from 180, that makes angle E 110. So you're probably going to see one type or the other. It was just the type that I printed out. It happened to be this type. This is the vertex angle. You're looking for the base angles. This second type that I showed you, you have the base angles, but you're looking for the vertex angle. So that's kind of the hard problem there. Okay, so what I'm going to do is I'm going to stop the video and then you hold your paper with you and we'll get the quiz turned on and you can work on that. Good luck.